Welcome to my channel, JaberTime. This video relates to the other videos. I'll put them at the end of the video as the last slide. It's a continuation to the transformation and functions and one-to-one and so on. They're gonna be all, I'll put them also on the link in the description below. So let's get into it. Absolute value functions. The graph says a lot. As you could see on the graph, we're doing transformations, and not only that, we're doing not just transferring the graph right and left or up and down. We're using a scale, which is a scale of 2 here. That's called vertical stretch. Let's get into it and see more about what is the transformations with vertical stretch. So the absolute value function is known to be, with this vertical lines. Sometimes we refer to it as distance away from zero, because distance cannot be negative. To enforce that, always if you have a positive number or zero, you keep it. But if your number is negative inside, you take its opposite. This is not a negative. The number is negative. The opposite will be positive. So it's always positive. What does that mean? Absolute value of x equals 5. That means either x equals 5 or x equals negative 5. So absolute value of 5 is 5. Absolute value of negative 5, because it's negative, we take the opposite and becomes 5. So what's the solution for this? It's either 5 or negative 5. Notice that 5 has a distance away from 0, which is 5, and negative 5 has a distance away from 0, which is 5. You're saying, what values of x do I have here that they have a distance of 5 units away from 0? Because the inside part could be written as absolute value of x minus 0, but it's not written minus 0, so we're taking the distance away from 0. How about if you say absolute value of x less than or equal to 5? So you need the distance to be less than or equal to 5 from 0. That means you should be from negative 5 to 5. Because of the equal sign, those are closed, including the negative 5 and 5. Notice if I pick on 4, absolute value of 4 is less than or equal to 5, because absolute value of 4 is 4, and 4 is less than or equal to 5. If I pick on negative 2, absolute value of negative 2 is 2. 2 is less than or equal to 5. So all these points, they fit this right here, and this is another way to write it down. So whenever you have less than or equal, you could make it a compound inequality of this type. Now, it doesn't have to be a distance away from 0. It could be a distance away from 80. So if somebody says to you, I'm rephrasing the equation now. You could say it. Distance away from 80 to be less than or equal to 20. Away from 80, less than or equal to 20. So I should be between 60 and 100, including, because of the equal sign. What do you think? I'm not doing steps. I'm just doing the concept of absolute value and the meaning of distance away from 80. That should do it. No steps. If you want to do it with steps, we just think this way. So this much will be, that's what I have, less than or equal to 5, greater than or equal to negative 5 will be whatever I have inside, less than or equal to 20, greater than or equal to negative 20. I'm going to add 80 to all three sides. Well, same exact concept. That says it all. That's the steps. Your solution should be less than or equal to 100, greater than or equal to 60. Now, in real life, it's not always like this, x's and y's, or scores, or grades, or whatever. It is a real life problem. It says students who score within 20 points of 80 will pass a test. Using the variable p for passing, instead of x, that says it all. P minus 80, I was gonna say less than. Absolute value, distance away from 80, should be less than or equal to 20, and that is called the passing score. So if they score from 60, including 60, all the way to 100, that means passing 59 is not passing without steps. Now, to be more practical, I want to show you more examples and depth and detail with some graphs. Graph y equals 2 times the absolute value of x minus 3 plus 4. How do you do it? Well, this one has three things involved: the minus 3, the plus 4, and times 2. The correct way is to do it with steps, and you have to do it like order of operations, the correct steps. Here's the first step. We're going to focus on the corner point by moving the graph, because we can't move the graph point by point. So we're going to focus on the corner points or the vertex and things of that nature. So here's my first step. First, I need to know the basic graph. The basic graph looks like a 45-degree, and it goes this way as a V shape. All right. Now I'm going to work from inside out, just like order of operations. That's called grouping symbols. We're going to shift the graph to the right 3 units. Last video I described, why you go right, not left, and so on. So you might want to visit that video instead of me talking about and spending too much time here on more detail. Now, what do you think comes after? Should I be considering adding 4 or multiplying by 2? Think about order of operations. This is just like a hand. Multiply by 2. Well, when you multiply by 2, you're going to make it go up faster. The values will grow up faster, so it's going to be skinnier. And we call it vertically stretch by a factor of 2. You could describe it a lot of different ways. Let's just stay focused with vertical stretch. You could see, roughly speaking, that this is a vertical stretch compared to this one. It's just a quick idea. Then I'm going to consider adding the 4 on the side as my last step. So I'll bring it up 4 units to 3, 4 instead of 3, 0. So if you notice here, I'm looking at this point. I'm looking at the corner point or the vertex. And that's how things work out in graphs. You just focus on the corner point or the vertex and you move the graph. Here's the whole detail. Notice the first graph right here is centered at 0, 0. And look at this right here. That's 1, 1, right? You bring it to the right, 3 units, it's dashed red. You multiply it by 2, second step. You make it with a slope of 2, like 1 and 2. You could see it when you bring it up, it's clearly here than here to mark it. So I graphed it up there. Because this is going to stay the same opening between the green and the orange one. So that is the 2 that showed up. It's like the slope. If the first one was a slope of 1, this has a slope of 2 or a scale of 2. Okay, that's it for this one. Let's see some more examples. And I'll go a little bit quicker this time. Write an equation for the function graph below. I could see the scale 1, 1, 1, 1 all the way, so it's not stretched. And from this point to this point, it's just 1, 1. So there is no vertical stretch. All what I know is they moved it left 1 and up 2. And that's how you do it. Let's take another example. No vertical stretch. It's 1, 1. 45 degree. Same scale. Moved right 2. X minus 2. To support that 2 comma 0 belongs to us, plug in 2. 2 minus 2 is 0. Yes, 2 comma 0 fits this equation. Just in case if you wonder, like, should you write x plus 2 or x minus 2, you can just double check, plug in the point or any other point, and it's going to work. Oh, this is upside down. That means I have a minus up front. So move right 1 unit, move up 3 unit, and flip it. Move right 1 unit, move up 3 units, and flip it. That's called reflection about the x-axis, or called vertical reflection, which was covered last video. Here's another example. This is to the right 3, down 2, but look at the scale or the slope, it's not the same. You could see it 2. 1, 2 is one of the points given to me. I could see it, mark it. If you can't find the scale or the factor of stretching vertically, here's another way. If you are unable to determine the stretch, you can solve for the stretch factor by putting the known pair, for example 1, 2, of the values for x and y, or x and f of x. We know that we moved it right 3 and down 2, so this -3 and -2 outside, we know it, but we're not sure about a. Is it 2? Is it half? Is it? So here's one way to do it. Just rewrite it as y, plug in 1 for x, 2 for y, 1 for x, 2 for y. We picked a point from the graph. You could pick a different point, it doesn't matter. Now 1 minus 3 is -2. Subtracting, we have subtraction of 2. Add 2 to both sides. I get this. Absolute value of -2 is 2. Mental math, or divide both sides by 2. A equals 2. That's exactly what I said earlier, but if you're not sure, especially with graphs that they are curvy, like x to the second and x to the third, you can just use this method to find what is the scalar that I'm multiplying by to stretch the graph vertically or compress it vertically. So here's the equation, and that should do it. Next. Given f of x equals absolute value of 2x minus 6 and g of x equals 8, I want to set them equal to each other and solve. In other words, where is my absolute value be leveled at 8 on the graph? This is when we set them equal to each other. Now, here's a comment. It's good to know, actually. Notice that f of x equals absolute value of 2x minus 6, but if you take 2 out as a common factor, it is an absolute value function shifted right 3 units, stretched vertically by a factor of 2. Look at the graph. The scale is 1, 2, 3, 1, 2, 3, so it's not tricky, because sometimes if you don't pay attention to the numbers, we might think this is 1 and this is 1, but they might be going by 5 here. So you got to be careful. And if you notice right here, it's 1, 2. When these are clear, that to me means 1, 2. 2 over 1. So that is this 2. And that is this 3. So earlier, this is a comment for you, to graph this, you might think like I'm shifting it 6 units to the right. No, the graph is not shifted 6 units to the right. The graph is actually shifted 3 units to the right. You could plug in 3 and test it. Let's plug in 3 quick. 3 right here, not here. 2 times 3, 6. 6 minus 6 is 0. Yes, 3 comma 0 belongs to the graph. You could double check other points and that should do it. Now, they want me to see when this graph or this function f is equal to 8. Another function. Here's y equals 8 or g of x equals 8. They want you to find this x and this x value, which is from the graph, we could see it's 7 and -1. But let's say you don't have the graph and maybe it's decimals, it's hard to read from the graph. How do you do it? Steps. This is how we do it. We set the absolute value of 2x minus 6 equals to 8. We set them equal to each other. When you have equal with absolute value, you have two options. Either 2x minus 6 equals 8 or 2x minus 6 equals -8. The steps are so clear after that. add 6 to both sides. I'm doing it on both right and left to save you time. Cancels, 2x equals 14, cancels, 2x equals -2, divide by 2, divide by 2, 7 and -1. What did I say? 7 and -1. So this is equal to this at 2 locations, and that should do it. For this example, we have f of x equals absolute value for x plus 1. Then we're subtracting 7 outside. It says find the values of x such that f of x equals 0. In other words, they want us to see where this graph is going to cross the x-axis, because those are called zeros. So we have f of x equal. We're going to replace f of x with the value of 0. To do this, we're not ready yet to say or break it down. So we need to isolate the absolute value on one side of the equation by adding 7 to both sides, and now we are ready. Break it into 2 separate equations and solve by saying either equals 7 or -7. Subtract 1, I get 4x equals 6. On the side, divide by 4, I get 6 over 4, 1.5. On the other side, I'm going to subtract 1 again and get 4x equals -7 minus 1, which is -8. Divide by 4, I get -2. So when f of x equals 0, I get 2 roots or 2 zeros, which is 1.5 and -2. So the points are -2, 0, and 1.5, 0. To support it graphically, this is what I have. The V shape, the absolute value, crosses the x-axis at 1.5 and crosses the x-axis at -2. We could also support that this graph is shifted down 7 units. You could see that. I'm not going to go into much detail about this point here, but you could do it by pulling the 4 out and seeing this as 1/4. But that's not what the question is about. The question is about, how do you solve algebraically absolute value equations or functions. All right, let's take another example. This one is going to go quick. Solve absolute value of 3x plus 4 equals -9. Do you think I should go like plus minus, like 3x plus 4 equals -9 and 3x plus 4 equals +9? I don't think so. This is a tricky question, by the way. It should have no solution. Why? Because absolute value can never be negative. That should do it. That's it. All right? Just be careful. There is no way you could plug in any numbers right here and take the absolute value and end up with negative number like -9. Here's another example. What about if it's not 7 or 5 or whatever, like 0? That means I still have to solve it, but I don't have two options to go +0 and -0. So one option only. All right? How do you do it? Just regular way. I don't need the absolute value. What's inside has to be 0. It has to be. And subtracting from both sides, I get this. -5 times equals -10. That should be 2. Mental math. Or divide both sides by -5. And that should do it. We're done with this video, so I have another one coming, which is a lengthy one. Probably like 40 minutes to 45 minutes. Wait for it. I'm going to post it today also. It's going to have a lot of information about substitution, elimination, and graphing from different examples and ideas or angles. I have enough examples on it. It covers enough about inconsistent, consistent, dependent, independent solutions and how to solve. I'll see you on the next one, and thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.